Good afternoon, everybody. Welcome to SuperComputing 2019. Walter Hinton here from Pavilion. We are at the Western Digital booth, and we're talking about SCinet. SCinet is the high-performance network used by a number of different supercomputing entities here at the show. In fact, there's a wall behind me that shows a giant diagram of all the different touch points on SCinet. And one of the things that we're most pleased about is here with Western Digital, we are the storage array behind SCinet. So when they went out looking for high performance, high throughput, high IOPS, Harvey Newman from Caltech selected Pavilion and reached out to us to see if we would be the storage infrastructure behind this massive network. Of course, we said yes. And then we reached out to our friends at Western Digital because part of Pavilion's business model is an open choice of SSDs. And our friends at Western Digital were kind enough to offer us 72 SN200 NVMe SSDs. And this is a drive that is kind of near and dear to my heart. I was part of the team that launched this for Western Digital. So very happy that we could be working together to power SCinet. So a little bit about this network. It is massive in bandwidth, spans multiple continents, and has the foundation for various simulations that are run here on the show floor. An example is LSST. This is a telescope that captures 6.4 gigabyte images times 15 times like every minute. So a massive amount of data that comes in from this is actually part of being able to find and image a black hole. Also part of this is the Large Hadron Collider. And again, with SCinet, this is simulations that are run with these types of systems across the network here at SC19. So if you go back over to Caltech's booth and they let you behind the curtain where all the gear is kept, and there's a lot of gear there, this is basically what you would see. You would see multiple 400 gig uplinks across the network. You'll see multiple 400 gig backbones that are servicing the show floor here today. They're transferring data in terabits per second and using servers plus storage from Pavilion and Western Digital using NVMe and NVMe over fabrics. So if you're not familiar with NVMe over fabrics, it's the next generation. If you had any experience with storage area networks in the past, separating storage from compute, allowing for greater high availability, allowing for more data services, this is the same functionality that's now being done over networks like Ethernet and InfiniBand using NVMe over fabrics. Lots of different institutions are actually running on this network, pushing their simulations over into Caltech's booth and down into the storage tier. So what's this hyperparallel thing? The world's first hyperparallel flash array. This is Pavilion's own creation, built for NVMe and NVMe over fabrics from the ground up. Probably our biggest differentiator relates to performance and density. So a combination of very high performance and a very compact footprint allows us to put over a petabyte of storage NVMe drives in 4 rack units. This system works both for scale up and scale out. So in many HPC types of configurations, you need to be able to go wide. You also need to be able to go deep. And we deliver that with up to 20 controllers, with up to 40 Ethernet or InfiniBand network ports, and the thing scales in a linear fashion and you operate it and you manage it in a way that's very similar to what you would do with the storage area network. A few weeks ago, we demonstrated controlling our system through VMware vCenter. We just got put on the HCL for VMware as well with our NFS solution. So you can use our own direct user interface. You can work through other tools. You can work through frameworks like those that have come forward from various working groups, Redfish, Swordfish, and the SCinet community. Whoops, go back. Multi-protocol and multimedia. So behind me, my friends here, John Collins is showing off an NVMe over Fabrics, just a bunch of disk. And while it's great and it works with RDMA or it works with NVMe over TCP, the thing that's unique about our platform is we can accommodate multiple protocols and multiple fabrics simultaneously. So you can have connectivity with Ethernet or InfiniBand. You can run RDMA-based transport as well as TCP-based transport. You can even run legacy SCSI or iSCSI and NFS all on the same platform, all at the same time. Part of what also sets this apart from traditional large packages of NVMe and NVMe drives is our ability to use our operating system to do what are just generally accepted storage functions. So snapshots, RAID 6, thin provisioning, and the one that I think is most intriguing, especially for this crowd here, as you go around and you look at different NVMe drives that are coming from Western Digital, from Micron, from others who are on the show floor, they're not making drives smaller, people. Those drives are going to get bigger and bigger and bigger. And as they get bigger, node recovery in a scale-out system becomes really problematic. So if you're putting NVMe SSDs directly inside servers, as these guys get bigger, the amount of time it takes to recover that drive goes up exponentially. So we're able to actually accommodate, we're running in some accounts a little over 15 terabyte drives, and recovery time for 12 terabytes is less than an hour. Another big part of the Pavilion business model is open choice storage. So unlike traditional storage arrays where you get to buy the drives from the guy who sells you the storage arrays, we actually unbundle that. So we kind of break the stranglehold that big storage has around storage arrays and SSDs. So you can choose from Western Digital, from Samsung, from others, the drive that you want for your specific workload. If you need endurance, if you need performance, if you need capacity, choose the right drive for your workload, populate those into our array, up to 72 of them for capacity. We also let you bring your own media. So if you happen to have built out a scale-out cluster and you want to redeploy those NVMe SSDs, you can do that with our system as well. So really it's a story of no lock-in, of hyperparallelism, and let's look at it just in a little more detail. So maybe. So shameless plug for Western Digital. They were kind enough to loan 72 SN200s to us for the SCinet backbone. So this array now is pushing just right at 90 gigabytes a second with Western Digital NVMe drives, up to right around 20 million IOs per second, and latencies that are measured in microseconds, not milliseconds. So let's take a peek under the hood. So this is the array. It's looking at it from the top down. And first thing you'll notice is this is a drive carrier. This is where I plug in these snazzy little WD guys, and up to 72 of those inside the chassis, giving you just about a petabyte of storage capacity in 4 rack units. The array also has, unlike traditional all-flash arrays, which are a dual controller architecture, we call this hyperparallel in that you can have up to 20 storage controllers in a single array. So as you need more performance, as you need more bandwidth, as you need more IOPS, add controllers and balance it with the right number of drives to go along with the system. You also see here fabrics. So these are 1.6 terabit non-blocking PCIe switches, fully hot swappable. Everything in the array is hot swappable. Controllers active as well. And then you see here, these are power and cooling modules. Maybe it's a little easier to look around the back. If we turn around to the back, you see the power and cooling modules. You're able to see management controllers. This is where we incorporate and enact functions like snapshots, thin provisioning. And then you can also see storage controllers and up to 40 Ethernet or InfiniBand ports. So it's really something unlike anything else on the planet right now. A disruptive business model with open choice, bring your own media, choose your own drives, and a hyperparallel flash array that can scale out to levels previously never seen. And just to kind of give you an example, this is the largest NVMe over Fabrics deployment in the world. This is well over 700 servers now, shared storage infrastructure with Pavilion Hyperparallel. Part of what this organization does is they collect massive amounts of data in the form of images, files, sound bites, facial recognition, all those types of things coming in real-time analytics being performed so that they can be very precise about decisions that are being made. So part of what makes this special is just a little bit of IBM's Spectrum Scale, also known as GPFS. Spectrum Scale provides the front end so everything looks just like a file system, single mount point across multiple nodes, but also these volumes are shareable. Meaning if I'm taking ingest from one thing and I need to put it somewhere else and I need to run other analytics, I can do all of this in motion fluidly behind Spectrum Scale. And you can see some of the performance numbers here. We're talking hundreds of megabytes per second read and write performance. And what I'm told is there's actually an update of this chart that takes it even higher. So, hey, thank you all very much for joining us here in the Western Digital booth. Walter Hinton from Pavilion. Appreciate your time. Look forward to talking about hyperparallel with you in the future.